Welcome to this series of introductory lessons related to the time value of money. My name is Brent Pritchard. I teach college finance courses, and I'm here to help you grasp this all-important concept. This introductory series is designed to help you learn how to apply the mathematics of finance in less than a month. Provided you commit to one or more lessons a day, it's really that easy. Acquiring the hard skill that is the mathematics of finance does not need to be hard. I hope you enjoy this fun new take on this age-old concept. And after you've done that, please consider telling your friends about this channel, TVM Rules, and the book, Would Your Boomerang Return, also known as the Boomerang Book that made it possible. I like to start every class with a quote. Here's the quote of this lesson. An investment in knowledge pays the best interest. Benjamin Franklin had it figured out, didn't he? Okay, here's how it's going to go. When you are analyzing or evaluating a real-world time value of money situation, either you're going to have the flexibility to choose which true investment yield to use or not. How will you know if you have the flexibility when it comes to choosing the true investment yield? Well, it comes down to whether you're dealing with a lump sum, i.e. single payment, or an annuity that consists of a series of PMT payments that are even or level in terms of amount and timing. We'll be going through a couple examples later in this lesson. How will you know if you can use the yield or rate that is stated or given? Well, you can only use a true investment yield, but it comes down to the right true investment yield. In other words, the time span of the true investment yield must match the time span in between periods or payments on the timeline. So that only leaves a simple investment yield and a true investment yield that doesn't match how you're telling time on the timeline. Either of those two won't do the job. How will you really know if you've got the flexibility or a yield you can use? Enter the 3-1-2 warm-up routine. It takes 3 and 1 to get to 2, and I'm referring, of course, to the TVM rules. First, you count money, next you tell time, and then you can read and write I, which is the true investment yield. The point of the 3-1-2 warm-up routine is to determine or calculate the I you'll need to apply the mathematics of finance, as described in TVM Rule number 2. But before we can do that, we must cycle through the mnemonic and audible aid indifferent in a 3-1-2 manner. First, TVM Rule number 3. What is the payment? In other words, a PMT payment or payment spelled out. In other words, PV or FV, a single or lump sum payment. In further words, an even annuity or a single payment. And then you're on to TVM Rule number 1, just like that. If you're dealing with an annuity, you don't have the flexibility to choose how you're going to tell time. You have to use the true investment yield that matches the timing of the frequent payments. Let's work through two real-world situations. For this first example, let's assume a 7.7633% true annual investment yield with monthly compounding. Let's further assume that you've got $1,000 burning a hole in your pocket. Wouldn't that be nice? And you plan to invest those monies. You'd like to know what you can expect for a future value after 1 year. In other words, a 1-year investment period. Now, before we move on, let's talk briefly about what we mean by payment. This word can carry a negative connotation, but I want you to have an open mind. I want you to be positive. TVM Rule number 3 tells us to pay attention to the different payment types and signs. We use both negative and positive no signs when applying the mathematics of finance, but that's different than having a negative mindset. If you think of a credit card payment, yes, I'm a student of Dave Ramsey. Every time that you hear the word payment, then I'm talking to you. As it relates to the time value of money, whether you're talking about a deposit, an investment, which carries a negative sign, or a withdrawal and receipt of money, which has a positive no sign value, it's a payment. It's that simple. Okay, back to the example. In this situation, you have the flexibility to choose which true investment yield to use. Why? Because you're not dealing with an annuity. If you wanted to tell time in annual terms, then you've got your I, your true annual investment yield. In other words, the stated yield works in this situation. Remember, a true investment yield considers the effects of compounding. And for the record, even if there's no compounding during the time span of the true investment yield, in the case of a true annual investment yield with annual compounding, it still considers the effects of compounding. So let's work through this first example. We've got our TVM wallet on the slide. This is our trusty visual aid, and we're going to work through the 3 windows. First, we're going to visualize. So in the first window that relates to TVM rule number 1, we're going to draw our timeline. When in doubt, draw a timeline. Again, this does not need to be now or today. There's nothing in the time value of money that says that time period 0 is now or today. It's simply the beginning of this 1-year investment period. So we're going to fill in the blank as we do. And we're also going to put a blank or a line in the subscript to uppercase N because we want to match the time span. We want to make sure we are focused on how we're telling time on this timeline. This is an annual period, so only a true annual yield will work. We'll put A down here in the subscript just to make sure we're on the same page. We have a 1-year investment horizon, so this takes the value of 1. Let's round out the TVM wallet with the other primary TVM keys that we find on our financial calculator. At time period 0, we'll put negative 1,000. Why negative? Well, because monies would be flowing out of our hands. We would be making a deposit. We would be investing the money. Because it's leaving our hands, it has a negative value. So over here in the third window of the TVM wallet, we put negative 1,000. So these represent financial calculator inputs. We're solving for the future value, so we're going to circle that. Are there any even or level payments? No, there are not, so we put 0 here for payment. Now, before we move on, I just want to recognize once again that the way we think about PV and FV and PMT payment, these are all kinds of payments. That's what TVM rule number 3 is getting at. Pay attention to the different payment types and signs. So we've got different payment types here. PMT payment represents an even, a frequent payment that is even or level in terms of amount and timing. We don't have that here, but we do have a single payment, and the way this story goes is that we're going to be investing the monies, and so it carries a negative sign here, negative $1,000. Because we're telling time with annual periods on this timeline, only a true annual investment yield will work. And we were told that the true annual investment yield is 7.7633%. And we're solving for the future value. So when we plug the numbers into our financial calculator for the future value, we get $1,077.63. So let's recap. Here we have the flexibility to choose which true investment yield we wanted to use. We were given, or the stated yield was a true annual investment yield because we wanted to know what $1,000 invested today might grow to after a year. If we wanted to assume a year on the timeline like we did, then we've got the true investment yield. The true annual investment yield, it works. So we had the flexibility, but we also had the luxury in this case of having been given a true investment yield, in this case a true annual investment yield that worked. So let's move on to the next example. Okay, the second real world example, you may have guessed that it was coming, considers an even annuity that contemplates monthly deposits of $100 for 1 year, starting 1 month from now. In other words, the payment is frequent and level or even in terms of amount and timing. So we'll be using the PMT key on our financial calculator. In this example, you don't have the flexibility to choose which investment yield to use because you're dealing with an annuity. You're being told how to tell time. But you still need to determine whether you can use the stated yield or rate. In this situation, only a true monthly investment yield will work. So let's work through the TMV wallet. Now, you may have noticed that we don't have the illustration here, but the TVM wallet, it's meant to be drawn. So let's do that. This probably isn't going to look as good as the one we were looking at earlier, but I'll try my hardest. So let's draw a TVM wallet. That's looking pretty good. There we go. We've got the first window, the second window, and the third window. Let's visualize what we've got going on here. This is still a year investment period, but we're telling time monthly. The first $100 is expected to be received 1 period from now, and there are 12 $100 payments. This is an abridged timeline. Those two lines tell us that whatever payment came right before continue throughout that period of time. So there are 12 $100 payments in this example. We're going to fill in the blank for that subscript, and we're also going to do it the way we do it. We're going to put another blank up there. How are we telling time on this timeline? Well, we're telling time with monthly periods because these are monthly payments. We're being told how to tell time. Let's complete this TVM wallet with the other primary TVM inputs that we find in our financial calculator. And so we're going to fill in the blank here, M. This investment period contemplates monthly periods. There are 12 of them, and there are 12 $100 payments. That is a payment that is even or level in terms of amount and timing. Now, we'll be covering this in a future lesson, but it's worth pointing it out right now. There's a relationship between PMT payment and N, the way that I teach how to apply the mathematics of finance. So the way that you can read this, even if you didn't have anything filled out in the first window of the TVM wallet, if you were only looking at the second window and the third window, you could interpret this to say there are 12 $100 payments. Because that $100 has a positive no sign value, you know that monies are expected to flow into your hands. They're expected to be received, or they're expected to be withdrawn, as opposed to invested or deposited. Because we're telling time with a monthly time span in between period markers or payments on this timeline, only a true monthly investment yield works. We've covered that already, but let's walk through how we calculate that. So up here, I'm going to draw I'm going to write out what is ultimately the building block true investment yield equation. So we started with a simple, which is a fancy way of saying nominal or doesn't consider the effects of compounding, annual rate of 7.5%. This is that rate expressed in decimal form, 0.075. There are 12 compounding periods over that year, so we put a 12 in the denominator. And I'm going to show you how, for the first example, we calculated the true annual investment yield of 7.7633%, because we're dealing with the same simple annual yield for this question set. Let's talk through this. So we start with a 7.5% simple annual investment yield. That shows up in the numerator. We're told that compounding happens monthly. So when we divide by 12, why do we divide by 12? Because there are 12 compounding periods over that duration of a year for the simple annual investment yield. What are we left with in parentheses? Well, we're left with a simple monthly investment yield. We add 1 to that within the square brackets, and then we kind of have to talk through this. So how many months are there in a year? There are 12. So we raise to the power of 12. That's how we calculated 0.7763 or 7.7633%, which was our true annual investment yield that we used in the first example. That was the first example. This is the second example. So now that we're telling time with monthly time periods, what do we need to do? Well, you'll see that only one variable changes, and we'll talk through this. So I'm going to delete what we've got here. We're going to fill in the blank with an M, because that's what we're looking for. But that's all that changes. So let's talk through this. We start with a simple annual investment yield of 7.5%. We're told that compounding happens monthly. So how many times would compounding happen over a year? 12. That's where we get the value for the denominator here. We add, and that is, what is it, that rate within the parentheses? It's now a simple monthly investment yield. We add 1 to that because we have to. That's what this building block true investment yield equation tells us to do. But then how do we take that 1 plus the simple monthly yield and turn it into a true monthly investment yield? Well, we just raise to the power of 1. We've got to subtract 1 because we want the decimal form. And when we do that, we get 0.00625 or 0.625%. That is the true monthly investment yield. Now, my financial calculator, my trusty HP12C, requires that I input the percentage format in when I'm solving for future value or present value. Your calculator may be different, but I just want to bring that to your attention. So here for I, I'm going to put 0.625%. And then we go about solving for the future value. It's really the future value of an ordinary annuity, as we'll get to this in a future lesson. And that future value, because that is what it is, a future value, is $1,242.12. It's really that easy. Let's move on to this, what I'll call a bonus example. Before we call it a wrap, I want to go back to this first example, and I want you to see how you could have used the true monthly investment yield. I mean, it made sense to use a true annual investment yield because we were telling time with annual time spans in between period markers. We were asked, what do we think the future value is going to be a year from today? It just made sense to use that given true investment yield that was a true annual investment yield. However, you had the flexibility. Why? Because you were not dealing with an annuity. You were dealing with a single payment or a lump sum payment. So here, before we call it a wrap, I want to show you how you could have used the true monthly investment yield. Okay, I'm going to draw a TVM wallet again. This is our visual aid. It helps a lot of students. Students seem to really like it, and that makes me happy because it prevents analysis paralysis, gets you off on the right page, on the right foot. So in the first wallet, we are going to, in the first window of the TVM wallet, we're going to draw out a timeline. We've got our bridge lines again. We're going to fill out the windows with the 5 primary time value of money variables or inputs. There we go. Now, remember, we had $1,000 burning a hole in our pocket. And we want to know the future value after a year, or better said, in this example, after 12 months. So we're telling time monthly, so only a true monthly investment yield is going to work. We're going to put M in there for the subscript for N, uppercase N, again, so that we remember how we're telling time on this timeline. In this example, there are 12 periods over the investment horizon. For payment, let's put in 1,000, but it's not a positive no sign value. It's negative. Again, why is it negative? Because those monies would be invested or deposited. They would be leaving our hands. What about PMT payment? There's not a frequent payment here, so that takes a value of 0. And again, let's just walk through how we calculated the true monthly investment yield. And I'm going to start by writing out the building block true investment yield equation if you haven't seen that lesson already. So we've got S for the simple investment yield, C for the number of compounding periods over that duration for the simple investment yield. We've got lowercase n minus 1 equals I. There we go. That is the building block true investment yield equation. We were told in this question set that the simple annual investment yield is 7.5%. So that's 0.075. That's the decimal form of 7.5%. We were also told that compounding happens monthly. So there are 12 compounding periods over the term of a year. So within parentheses, again, what we're looking at here is a simple monthly investment yield. How do we get a simple monthly investment yield to a true monthly investment yield? We raise to the power of 1. And when we do that, we get 0.0625 or 0.625%, which is I, which in this example is a true monthly investment yield. 0.625%. And when we solve for the future value, we get $1,077.63. Oh, let me fix that 63 cents. We don't want to forget about the cents. So if you were to go back to that first example, or if you're remembering what we calculated for a future value for that first example, you may recognize that number. See what I mean by being indifferent. So let's talk through what that means here in this example. You would be indifferent between $1,000 today and $1,077.63 to be received a year or 12 months from today, provided you expected that you could earn a true monthly investment yield of 0.625%. So that's a wrap. If you liked what you learned in this lesson, please consider telling your friends about this channel, TVM Rules, and the book that made it possible. Prior to this book being published, every publication I had reviewed on the topic fell short of not only what I wanted, but what I think aspiring and current finance professionals and teachers need in terms of a resource related to the time value of money. It's not uncommon for traditional finance textbooks to devote only one chapter to the single most important topic related to finance and money. You see me shaking my head? It's wrong. To say that these other publications fall short, it's an understatement to the nth degree. If you haven't purchased your copy yet, all the important information on this all-important topic is gift-wrapped within the cover of Would Your Boomerang Return. Until next time, enjoy the gift that is the present.